Hello students, this is our second part in the chapter alcohols, phenols and ethers. In our previous session, we have studied about the introductory part and the classification along with nomenclature of alcohols. Today we shall see their methods of preparation. Methods of preparation of alcohols. The first method of preparation of alcohols is from alkenes. We know what alkenes are. Alkenes are the unsaturated compounds which contain carbon to carbon double bond in them. So, utilizing alkenes we shall now prepare alcohols. Under alkenes, the first method is by acid catalyzed hydration. What is hydration? Hydration refers to addition of water. Addition reactions are generally done for unsaturated compounds, those which contain double bonds or those which contain triple bonds. You cannot easily carry out addition reactions for saturated compounds or single bonded carbon containing compounds. For this reason, addition is generally done for unsaturated compounds. In this reaction, hydration refers to addition of water. To which compound are we adding water? To alkenes in the presence of an acid as a catalyst. So, the general reaction is take simplest alkene, that is ethene. When ethene is reacted with water, or in other words you can say when water is added to ethene in the presence of acid as a catalyst, the product obtained is, you split this water as H and OH. Add H to one carbon, remaining OH to the another carbon. Then product will be CH3, CH2, OH. It is ethanol. So, how do you convert ethene into ethanol? By reacting with water in the presence of acid as a catalyst. So, this question will be asked in the annual exam for 3 marks as to explain the mechanism of acid catalyzed hydration of alkenes. For this there are 3 steps. The first step in hydration of alkenes is protonation. It is protonation. How is it done? First, any acid is reacted with water so that it generates hydronium ion. This H plus cannot be easily added. It is very difficult to isolate a proton and add it to a compound. For that reason, we prepare a medium which contains protons. For this reason, acid is dissolved in water so that it generates protonium ions or hydronium ions. This hydronium ion is reacted with alkene. You can write this as in this form. So, when hydronium ion attacks alkene, this alkene takes up one hydrogen and it becomes CH3, CH2 plus. This carbon took one hydrogen, so it became ethyl carbocation. It became ethyl carbocation. Remaining is water as it is. So, the second step is nucleophilic attack. Nucleophilic attack of water on ethyl carbocation. These two will again react with each other. H2O, HOH. So, when water attacks on ethyl carbocation, this becomes a protonated alcohol, that is CH3, CH2. O, H, H and H. This and the product ethanol, they are differing only by a proton that needs to be removed. So, removal of proton is called deprotonation. So, the third step is deprotonation, wherein our protonated alcohol is deprotonated to give us alcohol. In order to remove a proton, you again need you again need a solvent which can extract protons. For that, water is the best solvent. So take another molecule of water. This will take up one proton or one hydrogen, giving you the final product CH3 CH2 OH plus H3O plus. Now what happens to this hydronium ion? That is none of our worries. Our intention is to prepare ethanol as a product. So how is it prepared? By reacting water with ethene, you will get ethanol. This reaction is done in the presence of acid as a catalyst. Now this reaction has 3 steps. The first step is formation of ethyl carbocation. This is done by reacting a given alkene, that is ethene, with hydronium ion. In the second step, the ethyl carbocation is attacked by a nucleophile, that is water. As a result, you will get protonated ethanol. In order to remove a proton from ethanol, you take another molecule of water which will eliminate one proton, giving you the final product ethanol. This is your first method of preparation of alcohols by using alkenes and by acid catalyzed hydration. The second method is again from alkenes, wherein you have another set of addition reactions, that is called by hydroboration. By hydroboration and oxidation of alkenes. A very typical reaction. You know what hydration is? Hydration refers to addition of water. Oxidation means addition of oxygen. Similarly, hydroboration refers to addition of boron and hydrogen. Addition of hydrogen as well as boron is called hydroboration. For this reaction, you need diborane as a reagent. So take an alkene, react this with diborane. React this with diborane. Now when these two react, diborane gets added on to alkene, therefore the reaction is called hydroboration. When these two react, it forms trialkyl borane. It forms trialkyl borane. In order to balance 2 molecules of trialkyl borane, here 6. Now the product is triethyl borane. In general, trialkyl boranes are formed due to hydroboration. After trialkyl borane is formed, that is triethyl borane is formed, you react this triethyl borane with any good oxidizing agent. Preferably hydrogen peroxide is used because it is a strong oxidizing agent in the presence of an alkali, that is any base like sodium hydroxide. As a catalyst, this reaction proceeds faster. Now what should be our product? If you are able to understand this, fine. Otherwise, you split this molecule into 3. I will write this in the split form, CH3 CH2. It is 3 times, so I will write thrice, CH3 CH2 CH3 CH2 thrice with boron. Understood? This is triethyl borane. Now when it reacts with hydrogen peroxide, you understand or you imagine hydrogen peroxide as HOOH. You have cut this molecule into 2. So OH is one part, another OH is another part. So for that reason, you need to form alcohol using this triethyl borane. For that reason, you break the bond here, utilize one OH here, the other OH this side. Again break here, one OH here, another OH here. So 2 molecules of hydrogen peroxide. Again third molecule OH here, OH here. So how many molecules are you going to write here? You write 3 molecules of hydrogen peroxide are used as an oxidizing agent in order to oxidize triethyl borane. Now what is your product? CH3CH2OH. How many times did it appear? It appeared thrice. There are 3 molecules. This is one molecule, the second molecule and the third molecule. So write 3 molecules of ethanol are formed, and the second product is BOH thrice. BOH thrice. Or else if you find writing this as difficult, then you can write H3BO3. Understood? This is second method, by hydroboration oxidation of alkenes, wherein you react diborane with ethene, it will give you triethylborane. Triethylborane is further oxidized using hydrogen peroxide as an oxidizing agent in the presence of a base or alkali like sodium hydroxide. This will give you the desired ethanol as a product. Now this was first method from alkenes. Under alkenes we had two methods. First was by hydration, acid catalyzed hydration, and the second was by hydroboration oxidation. Now let us study the second method from carbonyl compounds. Methods of preparation by using carbonyl compounds. You know what carbonyl compounds are? Carbonyl compounds are those compounds which contain this group. C double bond O group is carbonyl group. If this carbonyl group on both the sides has an alkyl group or an aryl group, then it is a ketone. If on one side it is alkyl, on the other side if it is hydrogen, then it is an aldehyde. If on both the sides it is hydrogen, then also it is aldehyde. Therefore, if C double bond O group is flanked or attached on both the sides by alkyl or aryl groups, it is a ketone. If it is attached on one side with an alkyl group, the other side with a hydrogen, then it is aldehyde. If it is having both hydrogens on either sides, then also it is an aldehyde. So our carbonyl compounds will have aldehydes and ketones. So utilizing aldehydes and ketones, how are you going to prepare alcohols? Now let us see. From carbonyl compounds, the first method under this is by reduction. By reduction of aldehydes and ketones. Remember, reduction refers to removal of oxygen. In other words, it refers to addition of hydrogen. You can say, sir, addition of hydrogen is called hydrogenation. True. Reduction is also addition of hydrogen or removal of oxygen. So reduction process involves addition of hydrogen, and anything that helps in reduction, which helps in adding hydrogen, is called a reducing agent. There are different sets of reducing agents. You can choose any one of them. The different sets of reducing agents are, remember these: by catalytic hydrogenation, that is utilizing gaseous hydrogen in presence of nickel or platinum. Catalytic hydrogenation is done in presence of hydrogen, nickel, platinum or palladium. Any one of these along with hydrogen can be used. If not, zinc in HCl. If not, lithium aluminium hydride. If not, sodium in ethanol, or else sodium borohydride. You have so many reducing agents, out of which you can choose any one reducing agent of your choice. What for? In order to reduce aldehydes and ketones or simply carbonyl compounds into alcohols. Now let us see how it is done. You choose any one aldehyde, say RCHO. This is an aldehyde. Now if you are reducing this by using catalytic hydrogenation method, that is by using gaseous hydrogen in presence of nickel or platinum or palladium, you need not write all the three, any one is enough. So if it is done, then if it is possible, write as it is, or else you can write it in its structural form, in this form. So you break bond here, I would say break bond here, here, add one hydrogen here, one hydrogen here, or else for this molecule simply one hydrogen here, one hydrogen here, two hydrogen atoms. So the product is RCH2OH. Simpler. This becomes an alcohol. Try this with some other compounds. If R is a formaldehyde, then you will get H and H, CH3OH, CH3OH. If R is an alkyl group, if it is an acetaldehyde compound, choose any other reducing agent of your choice. If I use lithium aluminum hydride, write lithium aluminum hydride on the arrow mark. This indicates that it is the reducing agent used. Now remember, only during catalytic hydrogenation use molecular hydrogen, otherwise you are supposed to write nascent hydrogen atoms. Whatever number of hydrogen atoms are given by lithium aluminum hydride, the same number should be indicated before square bracket. So in this case, here one hydrogen, here one hydrogen, so you write 2H. Do not write H2 if you are using any other reducing agent other than catalytic hydrogenation. Compulsorily you have to use nascent hydrogens and not molecular form of hydrogen. The product is CH3 CH2OH. Theoretically writing, this reaction is okay, but you should remember that lithium aluminum hydride is quite a costly reducing agent. For this reason, for at a lab purpose, at lab level, at laboratory level, writing this or practicing this is fine, but at large scale, at industrial level, this reagent is generally not used because of its cost involvement. Other than lithium aluminum hydride, you have many reducing agents which can be used, like sodium in ethanol or sodium borohydride or hydrogen in presence of any of these catalysts or zinc in HCl, any of them can be used. The only problem with lithium aluminum hydride is it is costlier, but it is a very good reducing agent to reduce organic compounds. Now this was by reduction of aldehydes and ketones. Till now we saw only aldehydes. Let us see ketones. R C double bond O R. This is a ketone. If it is reduced, use any other. I'll use sodium in ethanol. You can write ethanol as ETOH also, or else C2H5OH. That way is also fine. So where will you break the bond? Here, one H here, one H here. So two hydrogen atoms. So R CH OH R. Understood. The same you can try with another example of acetone, CH3 C double bond O CH3. When it is reduced using sodium in ethanol, you will have one hydrogen here, one hydrogen here. So CH3 CH OH CH3. What did you observe in this reaction? If it was an aldehyde, it gave you an alcohol. If it is a ketone, it also gives you an alcohol, but these two alcohols are different. Reduction of aldehydes will give you primary alcohols. Reduction of aldehydes will give you primary alcohols, and reduction of ketones will give you secondary alcohols. Always remember, reduction of aldehydes gives primary alcohols and reduction of ketones gives you secondary alcohols. Now this was one method under carbonyl compounds. Let us see the second method. By reduction of carboxylic acids and esters. I did tell you that carbonyl compounds are those which contain C double bond O group in them. If one side is R, if the other side is H, it is an aldehyde. If both the sides are alkyl groups or aryl groups, then it is ketone. Otherwise, if one side is alkyl or aryl group and the other side you have a hydroxyl group, then we call such compounds as carboxylic acids. They are carboxylic acids. If this hydrogen is replaced by an alkyl group, then we call these as esters. So they too are carbonyl compounds, but the only problem is that these are bifunctional compounds. It contains hydroxyl group as well as carbonyl group. So sometimes few people do not like to consider them as carbonyl compounds. No matter what, for our sake of convenience, we shall include these as well as esters. So what happens when a carboxylic acid and ester is reduced? It also follows the same reactions as aldehydes and ketones. For reduction of carboxylic acids and esters, you need again the same set of reducing agents. except sodium borohydride. Sodium borohydride cannot reduce carboxyl group, so never use sodium borohydride as a reducing agent in order to reduce carboxyl group. It is a very selective reagent which reduces only aldehydes and ketones and not carboxyl group. So one example, RCOOH, it is a carboxylic acid. If it is being reduced using any reagent, I will use lithium aluminum hydride. So what will be the product and how to guess? So first break bond here, give 2 hydrogens, one here, one here. So how many did you use? 2 hydrogens. Keep in mind there are 2 hydrogens here. Now this product is RCHO, it is an aldehyde. The other product is water. Now forget about this product is gone. Now this is only RCHO. Go back to your last method of preparation, wherein how did you reduce aldehydes? By breaking bond here, writing one hydrogen here, one hydrogen here. The product will be RCH2OH. RCH2OH. So the total number of hydrogens that you utilized in reduction of a carboxylic acid are 1, 2, 3 and 4. So write 4H. When will you write 2H? In case of aldehydes and ketones. In case of carboxylic acids, you need 4 hydrogen atoms. Sir, what if I write this method? A carboxylic acid with molecular form of hydrogen in presence of catalyst like nickel, platinum or palladium. Then you need 4 hydrogen atoms, but in the molecular form you need only 2 molecules. So the product will be RCH2OH plus H2 as it is. If it is an ester, RCOOR dash. This is done only to differentiate the 2 alkyl groups. If it is reduced, I will use another reagent, sodium in ethanol. Then here 1H, here 1H. One product is alcohol, ROH. The other product is again RCH2OH. So how are the reactions of carboxylic acids and esters different? Carboxylic acid gives you only one alcohol, that is primary alcohol, whereas an ester gives you 2 different sets of alcohols. That is the only difference. And which reducing agent should not be used? Sodium borohydride cannot reduce carboxyl group, so it should not be used. It is a selective reagent only for aldehydes and ketones. Sodium borohydride does not reduce carboxyl group. Now this was our second method by carbonyl compounds. Now let us come to the last method of preparation of alcohols, which is by using Grignard reagents. You have slight idea about what Grignard reagents are. You have studied this in the last chapter, haloalkanes and haloarenes. What are Grignard reagents? Grignard reagents are alkyl magnesium halides. They are alkyl magnesium halides. So utilizing Grignard reagents, how will you prepare alcohols? Let us see. You first choose any aldehyde. I will choose formaldehyde, HCHO. For the sake of simplicity, you can write it as HCHO. This method also involves aldehydes and ketones. So along with this, you take a Grignard reagent, RMgX. You should also remember, whenever Grignard reagents are in picture, another reagent should be written on the arrow mark. It is compulsorily dry ether. Without dry ether, the reaction will not proceed. At least in the initial stage, when Grignard reagent has to react with some compound, you are supposed to add dry ether. Now separate this part, attach R to the carbon and the remaining part to oxygen. So H dash C, upwards H, here R, then O, then Mg and X. Because this product is unstable, we represent this in square bracket and call it as an adduct. An adduct is an addition product. Now once when this adduct is formed, you hydrolyze this in order to get the required product. Hydrolyze in the presence of acid. We call this as acid hydrolysis. The product is, you break the bond here, add H here, OH here. One byproduct is Mg, OH and X. The other is R dash CH2 dash OH. So you got alcohol. You got alcohol as the product. Other than formaldehyde, choose any other aldehyde. RCHO. React this with a Grignard reagent RMgX in the presence of dry ether again. This should not be forgotten. Attach R to carbon, R dash to the carbon and the remaining group to oxygen. Then you will have RCH R dash O MgX as an adduct. Hydrolysis of which will give you H here OH, R, C, H here R dash OH, and the remaining part is Mg, OH and X as it is. This also is an alcohol. Now choose any ketone, R, C, R double bond O, write in this form. React this with a Grignard reagent RMgX in presence of dry ether. Attach R to the carbon and the remaining part to oxygen. Then you will have RCR R dash OMgX, an adduct. Its hydrolysis will give you RCR R dash OH plus MgOH and X. This is also an alcohol. Whether it is aldehyde or ketone, if it is reacted with Grignard reagent and further hydrolyzed, the products are alcohol, but all alcohols are different. If it is formaldehyde, only then you will get primary alcohol. This should not be forgotten. Only formaldehyde upon reacting with Grignard reagent gives you primary alcohol. Other than formaldehyde, you take any other aldehyde. You take acetaldehyde, you take propionaldehyde, any other aldehyde, they will give you secondary alcohol. All ketones give you tertiary alcohols. This is tertiary alcohol. So how is Grignard reagent reacted with aldehydes and ketones? When it is reacted with formaldehyde, you will get primary alcohol. All other aldehydes will give you secondary alcohols and ketones will give you tertiary alcohols. So today we studied 3 methods of preparation. The first one was from alkenes. Under alkenes there were 2 methods. First was by acid catalyzed hydration. There are 3 steps whose mechanism is important for exam. The second method was by hydroboration, oxidation of alkenes. The second method of preparations was by using aldehydes and ketones. Its reduction, by reduction of carbonyl compounds. The first was by reduction of aldehydes and ketones. The second was by reduction of carboxylic acids and esters. The last third method is by using Grignard reagent. What you should remember here, whenever Grignard reagent is used, compulsorily dry ether is used. If it is reacting with formaldehyde, only then you will have a primary alcohol. Other aldehydes give you secondary alcohols. All ketones will give you tertiary alcohols. The remaining part we shall see in the next session. Thank you.